CSUN's philosophy in terms of mechanical engineering is to give the students an applied, hands-on experience rather than a theoretical one.
One of the reasons I came to CSUN was because looking at other schools around LA, they didn't offer the support like this lab that it has for students. This lab is specifically for mechanical engineering students. That makes it a special part of the mechanical engineering curriculum.
I'm a freshman. Actually, when I came to open house, I was undecided, and when I came to mechanical engineering, I really liked that we can make a bunch of different things on the computer and just go and put them all together.
Industry needs students that are ready to begin working immediately. We give the students a hands-on learning experience by integrating design throughout the curriculum.
This mechanical engineering program is known all over the state for its high quality. It's very highly ranked, very highly regarded. And students in the program get to do such fascinating projects as part of their curriculum.
We've completed the design this semester and we're about to start manufacturing.
Anytime you go over to the department, its laboratories, you see students who are there working on these projects very intensely.
Pointing that direction.
Wait, is it really going to do that? Remember, initial coordinates?
Yeah, it thinks it's at 0, 0, 0 right now.
They're so engrossed and engaged in these projects that you know they are really enjoying learning.
What we're basically doing right now is checking our center of gravity height on the car physically and compare them to our measurements that we've made through the computer. We set the car on scales, 1 scale per tire, and we measure the weight of the car at a level height. So basically what we've done is we've done some calculations on the spreadsheet, and now we need to do a physical analysis of this center of gravity. We're on.
The Formula Car project is a senior project where our students get together and design and build a formula-style race car that meets or exceeds the needs of a weekend racer. After they build it, they take it to a national competition and compete against other universities.
We have a group of students who will design and eventually build a vehicle, and this vehicle eventually will go for a competition.
You have a path that's marked out in chalk lines, and your robot, it can be walking, it can be rolling, etc. It has to stay on this path and avoid obstacles at the same time. The robot that makes it through the path without hitting any obstacles, without going outside the lines fastest, wins.
We proved that simulation worked correctly. We implemented it using the LabVIEW software, and then we bought some cheap motors and built a small prototype to make sure that our simulation software was working correctly.
It needs to be able to see the chalk lines that outline the course. It needs to be able to detect any obstacles, potholes, things like that, and decide based on that where it wants to be and what direction it wants to be pointing when it gets there.
Here we are trying to implement edge detection algorithm. This basically is going to give us the edge of any obstacle in the camera frame. This is the output image, what you see here.
This vehicle should eventually have this kind of a human-like intelligence level.
It's like your baby that you've nurtured, and now it's grown up, it's going on out on its own and being successful.
Come on, Nick! Get in there, Nick! We had bulletproof glass, bulletproof plastic on the sides for the frame. That went in about one shot, almost completely knocking the bot out of commission. After that, it was just a matter of time before the guy just kept coming after us. This is my second BattleBot that I'm building. This is the rest of the group's first BattleBot. This is the weapons module that we have over here. This is going to be a rotating blade. It's going to be rotating at 2,000 RPM. The thing is, we've got it optimized so that when we are in competition, we've got the gear ratios right, we've got the power ratios right, so that we can actually deliver quite an impact. That blade is going to be moving at about 240 miles per hour at the tip. So when it impacts something, hopefully it's going to rip the armor right off it.
You're going through the design process with the math, and then you're designing on the computer, and then you get to actually build it, and you get to see it, and you get to see it working, and it's really exciting to be able to play with something that you just made, and it works great.
We have a lot of theoretical training, just like all engineering schools do, but we do put a big emphasis on our hands-on projects. Not only happen for the seniors, but also some of the underclassmen as well. So it's a balance between theory and practice.
The conceptual design, the brainstorming stage, followed by the critical design where we do the analysis, then manufacturing, and then testing. Those are all the parts involved in the design process. And we do all that in the lab.
To the reservoir. And then also another cool thing is we can mount the reservoir to these.
Much bigger hands-on approach than any other school that I've visited. We have projects that we get to work on, we have many labs, we get to use the machines ourselves, we're not watching someone else do them.
For the thermocouple, we're getting 1.03 volts.
Basically, they were using a sensor to measure temperature, which produces a particular voltage signal. That voltage signal then gets fed through the computer system and only out to the screen. So they're already learning how to use the software package to display those results in a usable form. So actually, you could go back to the front panel and try that one more time. Frequency is 5. Let's change that frequency to 1. So then we'll work, we'll get 20 samples, 1 per second, so it'll be a total of 20 seconds to give us a little time to debug things here.
In the Haas lab, we have a rapid prototyper machine, and it's used to quickly make things out of this clay powder. So basically, you don't have to waste time making an aluminum part that doesn't fit and doesn't work. You can make this little model and make sure it's exactly what you wanted it to be.
Print a layer, move down, print a layer, move down until the entire part is finished.
It just amazes me the level of technology that we're able to use in that lab that it wasn't even available 5 years ago.
We do have a rocket engine here, which is kind of unique here at Seaside. We have a rocket test cell.
Well, the San Fernando Valley is a very large place, over 2 million people, and we're surrounded by all sorts of high-tech companies.
You know, it's a great place to live. The San Fernando Valley has sun.
It's certainly most perfect weather conditions you could ever imagine. There's no winter.
There are internship opportunities that students have because there are businesses right here.
I got school credit and got to work at Northrop Grumman at the same time. And as soon as that was over, they hired me on as a full-time engineer.
A lot of employers will look for things like, oh, do you know this software package? Oh, you know SolidWorks. Oh, you know LabVIEW. And so they think, well, they already know this stuff, so we don't have to train them.
So that hands-on learning means that when they go out from here, when they graduate, they're ready to work.